How's everybody doing? Hope everyone's doing well at home and making it through this kind of crazy ordeal we're going through. As I go back and I look over the work, I've noticed that a few people have had problems with how we calculate gear ratios. So I want to go through the slideshow with you because this is going to be really important to what we're going to do in the next few classes coming up. First thing we want to understand is ratios. What ratios are, is there a number, a comparison of numbers actually, comparing two things. If you read the example, they compare oranges to lemons, all right? When we talk about it, we're going to be comparing two different gears and the number of teeth on those gears. Now, when we talk about ratios, they are a comparison of numbers. One thing I want you to remember as we go through this, we're not talking about fractions. As we go through these slides, a lot of times people get confused and they think of them as a fraction, and they're not. So the numbers we're not going to have improper numbers or improper fractions or anything like that. We're talking about how two things compare to each other. Other things we have to keep in mind, we talked a little bit about in class, were the types of gears we use or how we refer to the gears. The input gear is the gear that's going to be attached to the motor or the engine of the object. It's going to be the part that's attached to the power source, what's turning. If we're on a bicycle, we're the power source. So the bicycle, the power source is us. The input gear is the one that's attached to the pedals. The output gear is the one that's being turned, all right? In this case, it would be the gear that's attached to the rear tire of the bicycle. That's the output. It's the one being turned. This happens in a lot of different ways as we go through mechanisms, you'll see. But with this, just remember those terms. Input is the one doing the turning. Output is the one being turned. Now, when we get to calculate gear ratios, it's really a pretty simple process. What we're going to do is we're going to look at our formula we have. All right, our formula is gear ratio equals N out over N in. N represents the number of teeth that are on the gear. If we look to the drawing to the right side of our screen, we see input gear 12 teeth. So the input, the gear is 12 teeth. So N is basically equal to 12 in this case, and that number would go on the bottom. The output gear has 6 teeth. So the 6 teeth is going to go on the top and out. So now when we look at it, we have 6 over 12. This looks like something we did earlier when we did measuring at the beginning of the year, but it's not. Once again, we're doing a comparison of two numbers. But we are going to reduce these things like we did before. This time we're going to look for the greatest common factor. In this case, the greatest common factor is 6. 6 goes into 6 one time. 12 goes into 6 two times, giving us 1 over 2. Once again, this is where people get confused because it looks like a fraction. But it's not a fraction. It's a comparison of two numbers. The top number is going to go first when we change it to write it like a ratio. The bottom number will go second, giving us a 1-to-2 ratio. And what this means to us is for every one time the driver gear spins around, the output or the follower gear is going to spin around 2 times. I also want to make sure you guys understand that these numbers can be reversed. If we think about a mountain bike, we have lots of different gears, and sometimes we have a big gear that's turning a small gear, and sometimes we have a big gear that's turning a bigger gear when we ride a mountain bike. So in our case, we've changed the input gear. The input gear is now 6 teeth, and the output gear is 12 teeth. So this time, the 12 teeth goes on the top, the 6 goes on the bottom. 6 is still our greatest common factor, so we'll reduce those by 6, getting 2 over 1. This gives us a 2-to-1 gear ratio. which means that for every 2 times we pedal, our back tire is only going to go around once. And this is important because it allows us to use mechanisms to change speed or force. Remember, speed, obviously how fast we're going, and force, or the word torque, which we've talked about before, is what we're going to refer to as power. And let's look at why this happens. All right, if we're riding our bicycle, the rear tire of the bicycle circumference is going to stay the same. We know our back tire on our bicycle doesn't get bigger and smaller as we ride. The back tire is always going to stay the same size around. I guess unless we get a flat or something. But normally while we ride, the back tire stays the same size around. So we know that's not going to change. Do our legs get stronger when we pedal and weaker? No. What we do is we use gear ratios to change the way the bicycle is going to work. So with a 1-to-2 gear ratio, we would pedal around 1 time and our back tire would go around twice. So if we look at the diagram, we have a wheel and we have the circumference of the wheel, which we lay flat, we stretch out, and we can see in those red lines it happens 2 times. So what that means is on 1 pedal around, we would go that distance. On the other hand, if we changed our ratio to a 2-to-1 ratio, once again, our back tire is not going to change in size, just the way our gear ratio is set up is going to work. We're going to pedal 1 time around in a 2-to-1 gear ratio. That means the tire is only going to go halfway around. So when we look at our little diagram this time, it means we would go this far. Once again, did the size of the tire change? No. Did the power in our legs change? No. Did the distance we change change? Yes. So when we look at this overall, we can see that a 2-to-1 gear ratio gives us a lot more power. We have the same power in our legs, and we're not going as far using that power. In a 1-to-2 gear ratio, we're going a much further distance with that, so we would go much faster. And if you've ever been in a high gear on a mountain bike, and then start to ride up a hill, you'll notice it gets harder and harder to pedal. And if you don't change gears, eventually you won't be able to pedal anymore because your legs won't have enough power to make that tire go around 2 times. That's why we have to switch to a lower gear, like gear 1, that might be more like a 2-to-1 ratio, where we would pedal around 1 time and our wheels only going halfway around. Our legs would be going like crazy. We're not going to go too fast, but we're going to have the power to get up the hill now. So this is why we use gear ratios. And in the next few classes, we're going to go through a few more things with this so you can see how we use them in mechanisms and what these are and how these mechanisms work. Thank you.